A pre-trained language model is astonishingly capable, and yet, straight out of the box, oddly unhelpful. Ask it a question and it happily continues your text, because all it ever learned was to predict which plausible words come next. But plausible is not the same as helpful, honest, or safe, and there is no neat formula you can write down for what makes an answer good. So how did raw models become the polite, useful assistants we talk to every day? The answer is Rlhf, and it works in 3 clever stages. Let's walk through it. At its core, Rlhf is a pipeline of 3 stages that turn a raw model into an aligned one. Follow each stage in turn. Start with supervised fine-tuning. We take the base model and train it on example pairs of instructions and good responses so it learns to follow instructions at all. This is the SFT stage, and it gives us a model that can actually answer, rather than just autocomplete your prompt. Next, we train a reward model. We show human labelers pairs of the model's answers and let them pick which one is better, then train a separate model to predict those human judgments as a numeric score. In effect, it learns to imitate human taste. Now the reinforcement learning step. We optimize the language model, typically with an algorithm called PPO, to produce answers that score as high as possible under that reward model. The model is literally rewarded for pleasing human preferences. A real danger remains. Left unchecked, the model would drift into weird, repetitive text that games the reward without truly being better. So we add a KL penalty that measures how far it strays from the supervised starting point and gently pulls it back, keeping it fluent and anchored while it genuinely improves. So what does all of this actually change? Here's the before and after side by side. A raw pre-trained model predicts plausible text. It has read the whole internet and can imitate almost any style, yet it has no real notion of being helpful. Ask for advice and it might echo the question, ramble, or confidently produce something unsafe, because plausible was the only target it was ever given. Rlhf tunes that same model toward human preferences. Now it aims to be genuinely helpful, honest, and safe, because it was optimized against what real people judged to be the better answers. This is the leap popularized by InstructGPT and ChatGPT that turned capable but unruly models into assistants you can actually rely on. The behavior we wanted was never something we could specify in code, so we taught it from feedback instead. Strip it all back, and 3 ideas make Rlhf work. The first idea is alignment to fuzzy human values. There is no loss function for a good answer, so Rlhf learns those values from people directly, instead of trying to hand-code rules that could never capture what we actually mean. The second is the reward model. It converts messy human comparisons into a single score, giving the optimizer a clear target to chase across millions of updates, all learned from just a few thousand human judgments. The third is the KL penalty. It acts like a leash, stopping the model from gaming the reward into gibberish, so it improves on preferences while staying tethered to the coherent language it already knew. Alright, let's lock in what matters. Rlhf, reinforcement learning from human feedback, is the technique that tunes a language model to human preferences, turning a raw text predictor into a genuinely helpful assistant. It runs in 3 stages: supervised fine-tuning to follow instructions, a reward model trained on human comparisons, and reinforcement learning that optimizes against that reward. A KL penalty keeps the tuned model close to its starting point, preventing it from drifting off and gaming an imperfect reward signal into nonsense. Its costs are real, human comparisons are slow and expensive, and that is exactly why simpler methods like DPO later emerged. If you want alignment and machine learning demystified like this, come keep exploring with us over at standarity.com. See you there.